Here is another example where we don't have a picture, but rather a piecewise defined function. It's defined one way for x less than or equal to 4. We can call that the left-hand piece. And another way for x is greater than 4, that we can call the right-hand piece. It's asking about the continuity at x is equal to 4. First, we need to check the limit. If we're approaching x equals 4 from the left, it means we're using values of x less than or equal to 4. We will be, the top piece will apply when we're approaching from the left. If we were to put 4 in here, we would get 1/4 of 4 is 1 plus 1 is 2. So the limit approaching from the left is 2. If we were to come at x equals 4 from the right-hand side, we would be using the bottom part of the function here. We put 4 in here for x. We get 4 times 4 is 16. 16 minus 14 is 2, and this limit does exist because the limit from the left is 2 and the limit from the right is 2, so the limit as x approaches 4 is equal to 2. That's the first part of continuity. The second part of continuity is that we have to be able to put x equals 4 into this function and also get 2. If x is equal to 4, the top piece applies because we have the less than or equal to 4 here. We put 4 in here and we get 2. The limit exists as we approach 4, it is 2, and the value of the function exists at 4, it is 2. Since those things are equal to each other, this function is continuous at x equals 4. If we had a drawing, it would be one of those situations where the left-hand piece and the right-hand piece meet instead of there being a jump, as in the previous examples. Here's a more complicated example that is a really good business application. Here we have a candy factory selling candy by the pound, and with a lot of companies, you have a price break if you are ordering a larger amount here. You'll see the slope or the price per pound is lower. The reason that continuity would be important here is that we don't want some funky thing to happen at the point of the price break. For example, we wouldn't want a total of 26 pounds to cost less than a total of 24 pounds because of the way we created the discount. So we want this function to be continuous here, and in order for it to be continuous, we need the limit to exist, and that means that the left-hand side and the right-hand side have to match up when we put 25 in there, and that just means we have to set 1.25 times 25 equal to 1.20 times 25 plus k. We can pull in a calculator over here. 1.25 times 25 is 31.25. We'll make a note of that. And on the bottom function, 1.2 times 25 is 30. If we want the pieces of the function to match up, we need k to be 1.25. That way, when we put 25 into the top piece, we get 31.25, and when we put it into the bottom piece, we get 31.25, the 30 plus 1.25. If the pieces of the function match up there, and of course if we put 25 in, we'd be using the top piece, we'd still get 31.25. Everything matches up, the function would be continuous when k is equal to 1.25.